My name is John Misla. I work with the San Diego County Hazmat, and I've been interested in this topic for about 3 years. It's surprising how many inspectors and companies that have organic hazardous waste aren't aware of Subpart AA, BB, and CC. I'm primarily going to cover BB and CC, which are the most common regulations that are also adopted in California that apply to RCRA large quantity generators of organic hazardous waste. And you'll hear me repeat that quite a bit so people get in there, sort of a takeaway that we're talking about RCRA waste, organic, usually things with VOCs or semi-VOCs. And one of the things I did, I jotted down why isn't these regulations would have been around since the 90s in 40 CFR, why haven't they been implemented very well in our state? Other states have done it, like Indiana, Oklahoma, Texas, New York. I kind of boil it down like to 4 things. One, there hasn't been a lot of training on it, so that's what I'm trying to do today is train people about it. Second thing is the inspection tool. One of the handouts that we provided is an inspection guide. So people can take out, I based it on the RCRA guide. I tailored it to California regulation dealing with BB and CC, which applies to generators mostly. So that guide, I hope, is a tool that people can use, consultants, facility managers, regulators, engineers, because it's pretty much straightforward, even though a little bit more complex in terms of a regulation, because we're dealing with air emissions. It kind of made it easy for CUPA inspectors to follow, which is the sort of low-hanging fruit. Another misconception why it's not been enforced is people think that the air district regulates RCRA hazardous waste emissions. And so because they have an air permit to operate on the wall or in the office, they believe that the air district is sort of a shield or a permit that's replaces the RCRA air emissions rule, and that's usually not the case, and I'll go through that in more detail. And really the last one is the limited resources. Both the generator has limited resources to understand the regulations. They don't have a lot of money to spend on implementing them. Agencies don't have the resources sometimes, but as I've been doing it 25 years, hazardous waste inspections and so forth, and it really isn't that difficult. The resources aren't that hard if you're an agency trying to enforce this, and I could be used as a resource anytime. I do a lot of presentations and things like that. So, but I heard in a presentation yesterday that one of the EPA attorneys up on the second floor was mentioning that EPA Region 9 is going to start looking at BB and CC regulations, which I'll be covering in just a second, because they're finding in California, local and state inspectors aren't looking at RCRA organic hazardous waste, and while other regions have. There's been a lot of cases that have been done in other regions, especially in the southeast, Indiana area, Texas area, and things like that. Let's get started. Okay. So in my outline, I'm going to explain the applicability of the California and RCRA regulations for LQGs. I'm going to give some examples in the beginning, kind of make it sort of very photo intensive. Give an overview of BB, which is your equipment leak detection standards. And then overview of CC, which is tanks and containers. CC also includes surface impoundments, but we don't have any that I'm aware of in California that are legal, so I didn't cover surface impoundments. And then I go through the guide that I created. That's part of the stuff we emailed to the people that signed up, and all the presentations will be on the Cal CUPA website, I understand, in the next couple weeks or so. Why were these regulations created for RCRA air emissions? Well, the first thing was odors from TSDFs. It was 1990. There was complaints about it. There were bad odors coming from these facilities. Also, the hydrocarbons being emitted from these facilities were ozone precursors for bad ozone, the low-lying ozone, which is known to cause human health effects, especially for people that have like asthma, as well as they even impact how crops grow when you have ozone at the low level. And then air toxics from hazardous waste, things that are known to be bad for public health. The typical RCRA hazardous waste for this rules, I'm talking about, usually you've got your spent solvents, your F listing that Nick covered, are covered usually as an organic hazardous waste. D001 is usually flammables, liquids in particular, and usually they're captured by BB and CC. aliphatic hydrocarbons, chlorinated hydrocarbons, TCLP organics, and lots more. I'll give some examples in just a few minutes of some of the ones in San Diego, and I know in other CUPAs, there are companies that manufacture, that are doing production, that have these kinds of waste that's generated. When I talk about emissions, I'm talking about vapors and vapors everywhere. In this example, there's lots of points of vapors that are there. These little white clouds are being emitted from vents. I've seen valves and pumps leak. And then what's unique about organic vapors? When you got a slow leak from a valve or from a pump, usually they're going to evaporate. So the inspectors coming around, they're usually trained to look for puddles and ponds and staining and things like that. But what's unique about RCRA organics is a lot of them are going to evaporate and be an air pollutant. And so the valves and the pumps and the things that leak in the piping system are something I've seen. And of course, you've got your vents that occur in tanks and compressors and condensers and things like that that will also be an emission source for organic. I gave some really good references on the PowerPoints. If you want to learn a lot about this, EPA has an extensive amount of really good presentations online that I kind of self-taught myself this regulation and started to apply it in some of the bigger companies in San Diego. The Navy facilities aren't happy when we bring up BB and CC, but we're starting to look at some of their paint stripping when they do the aircraft refurbishing and so forth. And I'll talk about that in just a minute. But EPA's got some really good material. Okay. Everybody thought that this only applied to TSDFs. Well, in the beginning that was the case, but then EPA made the rule later on in the 90s that said we're going to apply it to large quantity generators as well. That's RCRA, organic hazardous waste. California also said we're going to adopt it. They had to keep their RCRA authorization. So you find it in the sections right here. This is the generator chapter 12, title 22. That points to the air emission requirements for LQGs. So you'll find it buried in chapter 12 in subsection A of 34. It points you to these articles there at the bottom, AA, BB, and CC. So you'll find them in chapter 15. That's where these articles are found, and for interim status. But that's what the generator regulation points you to, and all these regulations are coming straight out of that chapter 15. Okay. The inspection guide I made, I just developed it for this course. I'm trying to get all the inspectors in San Diego County brought up to speed on this, mostly the more seasoned advanced inspectors. It can be used by anybody. It references the California regulations. I took the EPA guide that EPA made for their inspectors and just spent a lot of hours translating the 40 CFR to Title 22, because that's what we enforce in California. And it's going to be available, like I mentioned, on the Cal CUPA website, and we emailed it, of course. Okay. So in San Diego, the ones I got involved with in terms of these hazardous waste emissions was the Navy's torpedo operation down at Point Loma. They were using mineral spirits to flush out the torpedoes from the torpedo fuel. Large Navy aircraft hangar where it's all sealed up and they do stripping with methylene chloride. So there's organic. The pharmaceutical manufacturing has been the funnest because they're starting to manufacture more in San Diego, and they're generating a lot of solvent waste. It's being piped outside to a wastewater treatment system. It's being piped to air handling system, condensers, vapor recovery units, thermal combustion units. So the vapors from pharmaceutical manufacturing I found to be the most enjoyable to inspect. They don't like it because it's sort of a deer in the headlights when you mention BB and CC. But I found it very interesting, and our approach has been start slow, and that's the recommendation I give to CUPAs is don't come in with a big hammer. It's an easy enforcement action to take, but I would go slow because this is something that people aren't aware of. So don't go in with a hammer is what I recommend. And we'll go through number 3 more in detail. I have slides. And number 4 was a large fuel terminal that supplies all the gasoline for San Diego County. They had a wastewater system contaminated with benzene, and that was stored in a tank subject to review for organic emissions. The The kinds of things we've seen at LQG inspections are open vents on tanks with emitting out vapors, organic vapors, VOCs and semi-VOCs, volatile organic compounds. No emission controls on these vents. They're not closed. They don't have a conservation vent, for example. There's no monitoring being done by the LQG for the vents or for the pumps or the piping that's going into it. They have no documentation when you ask about BB or CC. And so they are kind of like asking the inspector to help them out. I've seen leaking valves and connections and pipe runs. Pipe runs is Subpart BB. We're talking about that in more detail. You get leaks usually at seals, at pumps, at valves. You get some at flanges, and I'll talk about how that occurs. And I mentioned, like I said, leaking pumps. When we're talking about volatile organics, vapor pressure is important. So I put up a slide on what are some common vapor pressures for solvents. The greater the vapor pressure, the more volatile material. That's sort of a general rule. Okay? Gasoline has a very high vapor pressure. Obviously, it evaporates off very quickly. The greater the temperature, the higher a vapor pressure. So if something is heated, it is going to create a higher vapor pressure. And I put the last part down there, the equilibrium between the liquid and the gaseous phase. That's what a vapor pressure is inside of a closed container. So to kind of make it real simple. This is a pharmaceutical company that's got into manufacturing, one of the first ones I visited, and I mentioned BB and CC when I went in, and I knew the EH&S manager knew about it. And I asked him later why he knew about RCRA air emissions. And he said, I got fined in LA by the Region 9. They came in a few years ago and they did an inspection. So he knew about it, but he didn't comply here. And he told me why, which made sense at the time. So I went in. He had 2 totes, 350 gallons. It was VOC waste. The waste comes from production, which is over, here somewhere. And they transfer the waste through stainless steel piping into either tote, high VOCs, D001. I asked him if he had an air pollution permit. He didn't have one for this room. He had it for production. So the permit to operate from the air district was for the reactor vessels where they were making the material and where there's a lot of solvent being used. So that's where APCD required him to have a thermal combustion unit on the rooftop. This room was the waste room, the 90-day room, and it was very odor intensive. Solvent smell was really bad. And they had no vents that I could see on any of these tops. So why is the solvent smell so bad in this room? Matter of fact, he told me don't take pictures in the room, stay outside the room, which is where this is taken, because the flash may not be a good thing. And I'm like, oh. I'm like, uh-oh. So I didn't want to lose any more hair, so I stayed outside. So he said we have a wall duct that we have a blower on the roof, suck out the air from this room, especially when the EH&S technician is emptying these totes. They would empty out the waste as needed into 55-gallon drums. The guy would wear an APR. But he had already had all the answers that I needed. He was already thinking about redoing this room, taking the waste. This is inside, indoors, so it was really bad, and putting it outside to a 4,000-gallon waste tank. And this company's making billions of dollars in the last 20 years. So they got the money. It's just that he had to have his VP of facilities to approve it, and the money wasn't being approved until I went in and he used the inspection to get VP to approve the move outdoors, because this was not safe. He did a PSA, a process safety analysis, where it was really causing the technician to be overexposed to solvent. The APR was not really good, and a real flammable hazard. So.
Did you put in permits from the fire department?
He did put in. I was surprised. And I think in the beginning, this was put in 10 years earlier from this slide. It was different totes. They were portable, and they had grown. And every week they filled these up. So they had They really had their production had ramped up. In the beginning, it started small. So. Just some of the piping. This is where I can go in either tote. The pump, the little electric pumps that they had there. the source of a lot of vapors was coming right out of the electric pump because it wasn't sealed at the top. Remember, I didn't see any vents, so I said, where are all these vapors coming from? He said the tank top has all these little gaps. One of the major gaps is right there at the pump head. As it penetrates, the stem penetrates down into the tote. So that's where a lot of vapors were coming right out of a gap right around there. And I just tried to take pictures for it. You know, it was a very, luckily it wasn't operating at the time because he said it was operating, it couldn't even be near the area. And so, but one of the regulations that this rule requires is that you would do your monitoring of air emissions when it's operating. So when it was actually pumping and transferring, and imagine what the odors were, it was already bad to begin with. Another one we went out to in 07, they had a tote outside, again, VOC waste, 90-day storage area. They kept it open because the technician found it easier to keep the tote open to constantly pump from the 5-gallon safety cans. So that's an air emission violation. ABCD had no permit. This is an H7 hazmat storage facility or shed. And so ABCD didn't care about this, Air Pollution Control District I'm talking about. So it fell on our regulations to enforce it. So. Just to give you an idea, some of the clues you look for, you look at a manifest, the previous slide. You know, this company was a large quantity generator for sure. You know, they're generating lots of waste flammable, 4,400. So. They had no clue about air emissions. You know, they knew the inspector would write them up for not keeping their container closed, but they weren't even doing that. So. Kind of close up on the transfer pump. This is outdoors, so the odors weren't as bad as the previous business I went into, a different company. Again, they left it open. We wind up citing it because they was a repeat violation. You know, they had to implement air emissions, keep it closed. It was a tote, so it was a portable container. It wasn't a tank. So they wind up having to just do simple things like keep it closed. One of the regulations for container management of VOCs is that they have no splash loading. Because when you splash load waste into a tote, you got more vaporization. More vapors are kicked out. So. And we refer a lot of these to the fire marshal, and sometimes they come out and sometimes they don't. Yeah, as long as it's bonded and grounded and they got good ventilation and there's no ignition source and there's egress. Sometimes the fire departments, some of them may not take an active role in, because their aisle space was bad here, lots of other, I thought, fire code issues as well. This one I just went to just last year, just a few months ago, 5,000-gallon waste tank, methylene chloride, F002, so it's RCRA. When this pharmaceutical company was R&D, they went into manufacturing in 2010, 2011. And so they have a lot of waste put in a really great wastewater treatment system. But the BB and CC regulations, they weren't thought about. They did their tank assessment for hazardous waste tank assessment requirements, PE certified, but BB and CC, I could tell right away they didn't have it because you'll see one of the regulations, they have to mark everything with a tag if it's subject to BB and CC. And the solvent, I mean, I can look at the piping out there. Yeah.
Back up what you said last sentence.
Okay.
About having to tag.
Oh yeah, what you'll see, the regulation says that for flanges, vents, pumps that are part of RCRA organic waste, you have to tag it with a tag. And I'll show examples of it. So you have a unique identifier showing your production chemicals versus your waste organics. That's the intent of the rule. So they had a lot of piping, hundreds and hundreds of linear feet of piping with solvent waste, vapor waste, etc. When they say follow the piping, it's a little more challenging on places like this. You know, but you have the engineer with you, the guy running the wastewater treatment system, and you try and do your best. I was just taking pictures, and they allowed it. You know, we got flanges here, potential, drip points, leak points. Methylene chloride's pretty volatile. Again, if it does have a weep or a slow drip, what's happening to it is maybe not going to come out and be visible, it's going to be evaporating. So the intent is to keep the air pollution out of the air. Lots of connectors, lots of flanges and things like that. This is below the 5,000-gallon tank, a little sample port. Again, more flanges. Everything's really state-of-the-art. It's not old, it's not rusty, so I was pleased with that. Didn't have any leaks, visual leaks, didn't have any bad odors or anything like that. There was some safety issues that I couldn't get in close, and I didn't want to get in close. But it was, you could tell by the construction, it's new and it's stainless steel. The pumps for the waste goes into a 5,000 gallon tank. It's methylene chloride and water from their making their pharmaceutical drug inside their lab, the production lab, I should say. And it leaves the tank and goes out for treatment. So the 5,000 gallon tank's an accumulation tank. So it goes everywhere. When you look at all the piping, there's different routes for it to take. Ultimately, it goes to a steam stripper. That's a picture of the steam stripper, about 25 feet tall. And what it is, it just heats up the wastewater containing methylene chloride, strips out the methylene chloride from the water. Water goes to sewer. Methylene chloride is captured, decanted, put into drums. At the top of it, it kind of shows the condensers on top of it. When you're doing steam stripping, you're heating the waste. The volatiles are going up to the condensers. They're being condensed from the vapors into liquid, and then the methylene chloride is concentrated down in a tank down on the floor. All these are potential emission sources. As an inspector, you can't climb up there and get a PID and inspect it. So the regulation is very records intensive. What are the condensers? What are the designs of the condensers? What are the operating temperatures? Do they have records showing that it's within their parameters and things like that? Because if it isn't, you can have methylene chloride just coming out. You won't see it. And the wind will blow it, usually to the neighbors, and they may complain. But this was a tight system. There was no leaks. I asked APCD, did you guys permit the steam stripper? The answer was no. They didn't. It was wastewater with a little bit of methylene chloride. Less than 2% methylene chloride is what was in the wastewater. It didn't meet their action level for the APCD permit. APCD permitted the reactor vessels in the production lab, where the methylene chloride was going in at 40%, 50%. Permit to operate was for the vapors coming from production. So they had a very extensive APCD permit, but not for the wastewater treatment system out in the back. And so again, that's what we enforce. Again, everything was really labeled very well, so I was able to track the solvent waste, piping, and so forth. This is a decanter tank. They would get methylene chloride and water still, even come out of the steam stripper, and they would concentrate the methylene chloride, typical phase separation. A sight glass, often a point of where leaks occur, right there. Sight glasses, they can see the volume of the waste in the tank. Methylene chloride leaves the decanter and goes into these 55-gallon drums. That's a picture of the drum. They've got good, tight-fitting connections. But again, these are all potential emission points. All these connectors there where you can get weeping. And again, it will evaporate off and be an air pollutant. APCD didn't regulate this. No vapors, in good condition. You got a good sense of a good generator when they have a little diaper right there for the drips and things like that. I look for saturation, I look for wetness, I look for odors. CGI would not work here, right? Because it's methylene chloride, it's not flammable. So you need a PID, photoionization detector is what you would need. And I've carried them out to some inspections. They also have carbon absorbers to treat the vapors from production as well as from the vapor recovery system. The last one example I had was the fuel terminal in San Diego. They have an oil water separator. All the spills from the loading racks, the fuel loading racks, go to a drain system. They go to the oil water separator. The oil water separator has pumps on top, turbine pumps on top of them. They're pumping out the contaminated water. They pump it to a 18,000-gallon storage tank because they can't go to sewer with the benzene contaminated water. And this is a picture of the storage tank at the fuel facility. Pretty new because we had an issue and they replaced it. And what's there is see the vent right there, and right there is what they call a conservation vent. I'll talk about in a minute. But I went up there. It's not that hard to get up there. And I had a little PID right there. I sniffed the vent, and I was getting 300 parts per million of VOCs. At this place, everything smelled like gasoline, so he couldn't go by odor. Anything like that. So I had a PID. So I said, why are you getting 300 parts per million if your vent closure device is right here and it should be seated, should be sealing? So they took it apart and the guy installed it wrong. And I told APCD about it. Again, APCD was more concerned about vapor recovery at the fuel loading racks than they were about this tank that was 99.9% water and a little bit of benzene, because it was, benzene from gasoline. So they fixed it and the levels went down. But I really should have been doing a reading when it was operating, when it was being filled, but it wasn't being filled at the time. But as in a static state, I was getting 300 parts per million, and they were not happy because they had to keep track of their emissions even here. And again, just place where you would monitor. CGI would work, but I would use a PID. That's what I would suggest you have to use. I asked about when they offload this 18,000 gallon tank. This is a very good setup where they've got closed transfer points right there where they keep them closed. They're not dripping. They're not emitting vapors. So now we'll get into sort of the meat and potatoes of the regulations. Subpart AA is for specified equipment where they're doing, and we'll talk about in a second, certain treatment, like steam stripping, air stripping. BB is equipment leaks at LQGs. Okay. And CC is for tanks and containers, and of course surface impoundments, which I'm not going to talk about. In California, recycling units are potentially subject to AA, BB, and CC. RCRA gives exemptions. California says, we regulate wastewater treatment units, like that one I just showed with the steam stripper. That's a wastewater treatment system. Where if you went to another state, it would be exempt from these requirements if it's a wastewater treatment unit or totally enclosed treatment unit, and that's California. The lack of awareness is a big problem with this rule. LQGs often don't know about it. They think because they have the air permit that they're covered. So that's some education we need to work on with them. And inspectors are not trained to look for this. I'm hoping to get that word out and to use the inspection guide if it helps, because we want to try and be consistent from San Diego all the way up to Oregon. Again, these were enacted back in 90 and 94, 96. So they've been around for quite a few years. And again, large quantity generators are subject to the rule of RCRA hazardous waste. So not SQGs, not satellite accumulation areas. Those are not covered by the AA, BB, and CC. It's large quantity generator areas and RCRA organic waste. Most states authorized to do it. California was one of the last ones to be authorized. And again, they put it in Title 22, is where they put the federal regulation. I found that if a LQG has RCRA organic hazardous waste, especially D001 and the F listing, they're likely subject to BB and CC, and they don't know it. They will sometimes say we're exempt because we have an air permit. Well, sometimes that is only for production and the reaction vessel, the manufacturing unit, the paint booth, things like that, but it's not for their waste tank system, for example. The application of the rules are very detailed, and you'll see in just a few minutes. But one thing to remember is manufacturing process units are not covered by BB and CC. So emissions from a paint booth, when the guy's applying paint, that even though that's usually covered by an APCD permit, it's not a waste per se, because it's actually the application of the paint and going up and through the air booth to the top, usually to a catalytic combustion unit or thermal combustion unit. That's vapors from manufacturing. But if they were to collect waste in a container or tank, then it's subject to BB and CC. So if you try and apply the rule to manufacturing equipment, it doesn't apply because it's not subject. It's not a waste unit. Manufacturing vessel, manufacturing unit, things like that. And I give these hyperlinks. They're all active hyperlinks to show you where these rules and where these interpretations all come from. Again, not to go over the point too much, but the air permit, there is a duplication in the Clean Air Act and RCRA air emissions. The feds say, and California has agreed, of course, that if somebody has a Clean Air Act permit for that RCRA organic hazardous waste emission, and it's equal to the Clean Air Act rule under Part 60, 61, or 62, or 63. And they have active air equipment, air control, air pollution control equipment in use, and they have adequate records to show the Clean Air Act compliance. They don't need to meet BB and CC, but they have to have that nexus to Part 60, 61, or 63, which are these very stringent Clean Air Act, federal Clean Air Act requirements. For LQGs, a lot of them aren't subject to the 60, 61, and 63 because you're getting into literally tons of emissions, like from a refinery, before you're subject to some of that 60, 61, and 63. And sometimes the person that runs the facility will tell the inspector, you know, we don't need an air permit. We built this facility without an air permit, so they said we were exempt. Well, the exemption doesn't excuse them from the RCRA and Title 22 requirements. So that's one more air caveat to give you. Sometimes it's a hard understanding where the business says, you know, we went to the air district and they said we're exempt from the air rule, but now you're saying I have to put in vapor emission control. So you have to kind of explain it to them the best you can. And again, we kind of covered this in great detail. Now, the whole concept of RCRA air emissions is to have controls on the waste organics so that they're not evaporating, vaporizing into the air. They're based on unit-specific detail, the physical properties of the waste. Is it a gas, a vapor, or liquid? The organic content of the waste, it varies and is important. The action levels are the ones in the bottom here. Subpart AA, if you have a RCRA hazardous waste with 10 parts per million by weight, organic waste, that's Subpart AA. But you have to be doing treatment, air stripping, steam stripping to be AA. BB is a 10% by weight, a much higher level. If it's a VOC, semi-VOC with 10% or greater, you're subject to BB. Again, RCRA waste. And CC is 500 parts per million by weight. And again, it's all done at the point of generation is where the waste determination needs to be made for BB, CC, AA. It can't be done, you know, later on downstream. It's got to be done at the point of generation. AA and BB mention in the Federal Register total organic content, and it was kind of confusing. Why didn't they just say VOCs and semi-VOCs? Well, you know, EPA, they kind of muddle everything up, you know, and they use different terms in the time. And they thought, in the Federal Register, it said the reason why they used total organic content for AA and BB regulation is because at the time the Clean Air Act in 1990 was mentioning VOCs, and they didn't want industry to be confused between the Clean Air Act and this set of rules. So they used the term total organic content, which is a very wide open term, you know, total organic content. But really, semi-VOCs and VOCs are usually what are captured, D001, et cetera. And the waste determination, again, begins at the point of generation. The composition varies. If it's the waste is not homogeneous, sometimes it's got low VOC, sometimes it has high VOC. You got to deal with the worst case scenario for determining controls on your equipment. It could be done, the rule says, it can be done by knowledge or testing. Okay? Just adequate knowledge is important. Sometimes the manifest is what you got. The waste profile is what you got. The generator says, yeah, it's D001, it's a no-brainer. It's organic, RCRA hazardous waste. But you know, sometimes you'll have ones that have like the 2% methylene chloride. I had to explain to them why 2% methylene chloride in their wastewater treatment operation was RCRA hazardous waste. So I go, well, you're calling it F002. You know, oh, I thought it had to be 10%. I go, no, that's 10% before use. So I had to kind of explain it, and I'm going to work with them over the next few months because their system is pretty nice. But if they do sampling, they got to do 4 samples of the waste, point of generation, usually $300 a sample to get it tested. And they have to have a sampling plan. They just can't grab samples without thinking about where is the VOCs the highest in my waste, usually upstream, right? And they need to have that sampling plan available for inspector review and have the analyticals. The Navy did, I shouldn't use names, but a facility did some sampling for VOCs at the torpedo I guess the Navy thing is that's easy. Who's got torpedoes? At the torpedo area, and the lab sent them, they gave me all the data, and the lab said, you're using the wrong sample jars twice. You know, they did it over several months. And they go, you're not using the VOC sample jar. You're using a big old amber, 1 liter amber one. And you're losing VOCs when you're doing a sample like that. So when I wrote my letter back to the facility saying, you know, I'm not accepting your waste determination that you're below 500 parts per million in your torpedo waste tank. You know, and why are you doing that? I go, well, look at the footnote. You always read the footnotes in your lab report. You know, the chemist told the company that they needed to do the right sampling. Now, how is compliance demonstrated? LQGs, they got to have records. And they have to implement BB and CC. That's pretty much it. The choices for emission controls need to be documented. Vapor emission controls, what are they using? Activated carbon? Are they using thermal combustion? Are they using a closed system? Employee training. Who is doing the monitoring? Is the employee trained? And they can usually do it at the same time for a tank system as they're doing their daily tank system inspection for hazardous waste. They can usually look to see if there's an odor. Obviously, they can do it by visual or by olfactory means. That's what the regulation allows. If you smell something, you probably got a leak somewhere, even though you may not be seeing a puddle or a drip. AA, we're going to go through AA really quickly. The processes that are for AA are these. So not many LQGs are doing that, even though that pharmaceutical company I went into was doing steam stripping. This is like stripping of solvents from water, typically, or solvents from other solvents. And they're very low threshold, 10 parts per million. It's regulated under AA. Not very common LQGs, not very common at all. And they define what a process vent is for this rule. Pretty much open-ended pipe. AA, the control requirements were, you had to meet kind of a facility-wide process or threshold. It was pretty high. It was, you know, 3.1 tons per year or greater, you're subject to AA emissions or AA requirements. It was designed for TSDFs. That's the best way I can explain it. The AA rule was really designed for TSDFs that had a lot of emissions, that were getting all kinds of waste. It wasn't the same waste from different customers all the time. And so TSDFs really have what's called, you know, variation, tremendous variation in organic waste load. If they choose to use a control device, which AA requires, they have to have, you know, monitoring, closed vent system, control device. We'll go through that in a little bit. Now the rest of the presentation is going to be on BB and CC, which is usually what you're going to have at LQG record generators when you inspect somebody with organic haz waste. BB is a regulation also called LDAR, Leak Detection and Repair Program. And it's the piping runs. It's the pipes, it's the pumps, it's the valves, connectors, etc. They have to have inspect for leaks and repair when there is a leak within 5 days. 15 days is the maximum. The intent is for the LQG to have a leak detection and repair program. The BB said, you know, we want people to look for problems with emissions, vapor loss, and keep documentation that they're looking for it. And depending on what kind of waste it is, it could be weekly inspection, monthly, annual, and I'll talk about that in a minute. And they wanted, like I said, companies not to be complacent. Generators just, you know, you have your piping runs, you have your pumps, and you only deal with a leak when you see a big, you know, squirt or a big puddle or a big, you know, or when your inspector comes out and says, hey, you got a leak at your pump seal. So they didn't want generators to be indifferent about VOC waste, because VOC waste, again, is going to evaporate, especially outdoor equipment, especially in certain parts of the state where it's very hot, like the eastern part of the state. Imperial County, the stuff evaporates probably within, you know, minutes, depending on the leak. Again, LQGs are covered by BB. It's got to be RCRA organic. This is the equipment that's in BB. It's going to be your pumps. That's common. It's Compressors, no. For hazardous waste, I don't see them very many at LQGs. Pressure relief devices, yes. Sampling connection systems, not very common at LQGs. It could be. Open-ended valves in line, a problem. Valves for sure. And flanges and connectors. So at LQGs, you'll usually see several of these. I don't think you'll see compressors very much. Now the rule says that if you have equipment, that equipment I just listed, those 7 things, contains or contacts RCRA hazardous waste for 300 hours a year or more, you're subject to the rule. If you're below 300 hours, you're not subject to the rule. So if you have a piping system that is only being used for 200 hours in a year, you're not subject to BB regulation. But what does that contain mean? Contain or contact? In the Federal Register, EPA said, even though something is being used for a few hours a month, and it's below 300, if it isn't decontaminated after use, the piping system, the pump, and all that stuff, it's in contact with hazardous waste, and the Federal Register says, therefore, because it hasn't been cleaned and it's in contact with hazardous waste, even though it's not loaded with hazardous waste, all the piping runs are full, for example, it can still evaporate off. So unless you decontaminate it, you count all those hours when it's not being used. So if someone uses a piping run to transfer waste to a tank, and they're not decontaminating it, if it's in contact with RCRA organic waste, they're over 300 hours. The Navy was telling me that they use the torpedo cleaning like every quarter for like 10 hours. I said, well, do you purge it and clean it? You know, the mineral spirits? And no. I go, well, read the Federal Register. Because EPA said no, if it was in contact with RCRA waste, the possibility of evaporation can still occur unless it's been decontaminated. So Navy can change their process to get out of it if they want. That's easy to do, I think. But equipment and vacuum service is exempt, BB, and then SQGs are exempt. For the equipment, they have different monitoring and different parameters. Like light liquid service means an organic waste that's more volatile, is what it really means. Okay? So they're going to monitor weekly, monthly to detect leaks. Check weekly. Monitoring is using, the monthly monitoring is using a PID. So a company that's subject to BB with a piping run has got to go once a month to each of the places where there's threaded connections, the pumps, the flanges, and monitor with the PID, photoionization detector. That costs several $1,000s, and it's labor intensive. And see if there's any 500 parts per million or 10,000 parts per million, depending on the threshold. If they're getting hits on the PID and it's like 11,000 parts per million, you may not see a drip, but it's leaking. The valve is leaking, the pump is leaking. So that would be a violation. That would be a repair would be needed. So every month they got to document that. And in-light service means, you know, it has a certain vapor pressure and it's more than 20% in the organic waste. So there's all these definitions that make this a little bit more complicated. Okay. Pressure relief devices, you know, safety devices on tank top, on equipment, I should say. They should operate with no emission detected. Okay, when they're in a closed position, if they're operating correctly. And they have to repair. This is a big problem. The conservation vents that are installed incorrectly, like at that fuel terminal, the guy installed it incorrectly, so it was evaporating off. Waste sampling systems at an LQG, it's not very common. At a TSD, if they're doing a lot of waste sampling, you know, of what they got in their tanks. So I don't see too many waste sampling connections. This rule is not to regulate somebody going up to a waste pipe and taking off a little sample into a sample jar and doing it very quickly, within 10 seconds or less. It's designed for the big waste sampling connection systems where they're taking a lot of samples every day and there's a lot of VOCs from that sample. Open-ended valves and line. You can't have open-ended lines. The one thing at a facility I went to is their VOC system. They had a VOC waste tank and VOC piping leading to the tank. But then there was this open vent right on the rooftop. And I'm like, okay, you can't have open-ended lines, here at this operation. And it didn't have an APCD permit. It was waste. The CUPA should be regulating it and so forth. So they have to have plugs on the end of the or cap it. Or a second valve. Valves, often a point for leaks and emissions. Again, monitor monthly. EPA method 21 is the PID. And they should be using it when it's in operation, not when it's not being used, because that's when the waste is flowing through the valve. And anything more than 10,000 parts per million, it seems kind of high, but that's the standard they set. And they would monitor it. It would be a leak if it's above 10,000 parts per million. Now, what about if the valve is on the roof? And they call the valving and flanges and connectors, they have a term called unsafe to monitor, which means it's greater than 2 meters off the floor or off the ground. 2 feet, 6, 7 feet, whatever. So they said the industry doesn't need to regulate, doesn't need to inspect that monthly if they could put it in a plan, inspection plan, that they're going to inspect it at least once a year, preventative maintenance, whatever, or when there's a problem. And they're going to inspect it with method 21. And they have to document why it's unsafe to monitor. If it's 2 feet off the ground, you shouldn't buy that if you're an inspector. But if it's 30 feet off the ground, like that steam stripper area, that is unsafe to monitor. I should say difficult to monitor. The other term is unsafe to monitor, which means the employee that's going to be doing the monthly checking, getting to the area is unsafe, or it's unsafe up there. There's a lot of electrical equipment, there's trip hazards, there's confined space, things like that. So the company can have an unsafe designation. Again, at least once a year they got to go and monitor it, or when they know there's a problem. Everything else is pretty much heavy liquid or heavy service pumps and things like that. That's your VOC, which is not light, it's more heavy. It's not as, the vapor pressure is lower, I should say. And so it doesn't have all that immediate evaporation that you would with high vapor pressure. Repair requirements, the leak's got to be repaired within 5 days, start the repair, within 15 days, finish it. Somebody mentioned about, you got to tag all these connections and flanges and pumps, yeah. And so EPA, gave examples, and the industry has examples, these little metal tags with a chain around the connector or around the flange. It's the threaded connections they care about, not the welded ones. It's the threaded ones that have quick disconnects, things like that. So companies that are subject to it put a little marker on it. And that could be, if you're a big refinery, they usually are subject to these rules under the Clean Air Act. That could be a very daunting task, but the company with a pharmaceutical one, they know about it, and they have actually tags on a lot of their equipment, and not on all the threaded connections, which is an issue, but they've started the process. In their record keeping, they have to have the IDs of the connectors, pumps, valves, etc. Location, type of equipment, the waste state. Is it 30% organic? What is the waste composition? Control method. Is it a closed system? Is it a vented system that's being vented to an emission control system? All that stuff needs to be documented and needs to be recorded. Record keeping for leaks, they need to, again, have records. I'm going to go quickly through this because we're kind of running out of time, but, and that's the thing that it takes a lot, not only the monthly monitoring, weekly monitoring, records are a big deal. And it takes a lot of time. You have to dedicate an employee who's trained to do it. And for big companies, they usually can find the staffing. Or some big companies will actually have a consultant do it once a month for them. That's because EPA usually dinged them in another state. Subpart CC is containers and tanks. And I put this slide in here because vapors can be not only an air pollutant, but they can really be a problem. And this is 2003 outside Houston. These guys got killed. They were offloading VOC waste at this TSDF facility. These fire guys are fighting the fire, and there's a big, huge fire back here. The vacuum trucks are burning. And, I read if you go on this link, I read the safety report on it because the Chemical Safety Board did an investigation on why these three guys die. And, they had fans up in the roof to blow away the vapors. That was their emissions control. To keep, what happened was there was an ignition source, heavy vapor buildup during an offload of the waste, and it wound up killing 3 guys. This is 2003. So vapors are not only an air pollution issue, it's a safety issue, as you all know. Really good PowerPoint EPA has on Subpart CC. I highly recommend you look at it. It's 100 and some slides, and you'll really get, by going through it, you'll really get a good sense of the whole Subpart CC, or a good afternoon nap. Organic vapors. There's breathing losses. Breathing losses are from a tank coming out, the vent on top of a tank. It's caused by, temperature changes. Okay? It could be 50 degrees in the morning, and late in the afternoon, it could be 95 degrees. All that stuff's heating up, and vapors are coming off, especially on the certain parts of the state. That's why I put at the bottom, Santa Barbara versus Imperial County or Mojave. Look at the temperature change. Working loss is when you're filling it. Where's the headspace going? That's what's called a working loss. So there's calculations EPA made for these big bulk tanks for hazardous waste where when they're being filled, they're calculating hundreds of pounds a week of VOC emissions from these bulk hazardous waste tanks at TSDFs that were being vented before this rule. Literally tons and tons of emissions from working losses. Again, CC applies to tanks, RCRA hazardous waste tanks, and containers. I'm not going to talk about surface impoundments, like I mentioned. And the threshold is 500 parts per million by weight or greater is CC. So it's much lower than BB. BB is 10%, much higher, 100,000 parts per million. There are exemptions California and RCRA have. All these are exempt from CC. Satellite containers, SQGs, and the rest of them I'll let you look at. Title 22 has the same definition for VOC that EPA has. Okay, and these are the definitions of a VOC. Typically 8240, 8260, 8270. Those are the EPA test methods for grabbing or analyzing the waste for those constituents, or hydrocarbons. Subpart CC says you can do it by direct testing or by knowledge. You don't have to order somebody to do sampling. If you're an inspector, they can do knowledge. They have to be right. The generator has to be right. And it's got to be the VO determination. If they have 5 waste streams, they shouldn't give you one record of analysis for one waste stream and say, this is our record that shows 100 parts per million. Well, then you're going through and you're talking to production. They say, yeah, we use 30% methylene chloride, and yeah, it goes out to that same tank. And it's like, okay, you got handed something that wasn't representative of another waste. So watch out for that, because I've had that in my career where I get a profile and it's like, then you go to production and it's different. The analytical methods are specified in a rule. EPA likes 25. It's a very good method for determining VOCs. That's the one they recommend if somebody's doing sampling and testing. And the reason why is kind of spelled out on this slide. It's a very good one. It can be used for all kinds of well-mixed waste, phased waste, solids, liquids. And the Federal Register says, EPA, we prefer this rule. Better than 8260, 8270. And you'll have to talk to the company about it, the generator about it, because they may do 8260, and it'll screen for the constituents that are in that method. But like with the Navy, I was like, wait a minute, the fuel in your torpedo is not showing up in 8260, so the method isn't picking up the volatiles from the torpedo fuel. So I said, maybe you want to think about 25. That'll pick up everything. So you got to check that sometimes. Again, representative, point of generation, worst case, annually update it. They can do it by knowledge annually, once they have that direct testing, for example. For tanks, EPA says you got to do, you got to know your 500 part per million threshold for waste going into a tank for organic. You need it to determine level controls. Tank level 1, we're getting into in just a minute. And if you want to do no detectable emissions from a tank, you got to use method 21. So you got to know your composition for your waste. Bottom line. For containers, the same thing. This rule applies to hazardous waste containers, drums and totes, etc. You got to know your average VOC content. Is it 500 or greater? You got to know vapor pressure if you're putting it into a bulk 122 gallon plus tote or container. And if you want to do a no detectable emissions, you got to show method 21. All that has to be done by the generator, not by the regulator, by the generator. Again, same exclusion. If you comply with Clean Air Act, it applies. They have Clean Air Act controls. They may not have to implement CC. Process knowledge, just the generator can use knowledge, is okay if they're right on their waste process and their organic composition. There's 2 levels for tanks, level 1, level 2. Level 1's the easiest. The most common one, 90% of the time, inspectors and LQGs are going to be tank level 1 if they comply. It's pretty simple. Because they haven't got a steam stripper. They haven't got a lot of treatment going on, for example. And I'll go through these levels in just a second. Waste tanks become more challenging with vapor emissions because you got to know the vapor pressure of the waste in a tank. What is the highest maximum vapor pressure? That's important. Conservation vents that don't close. That is allowing emissions into the air. Interaction of BB and CCs. A company says, I don't have 10% in my waste. I go, no, that's BB. CC is 500 parts per million. They're like, ugh, you guys. For inspectors and for the business, inspection safety. I'm not climbing on that steam stripper, at whatever I make an hour, minimum wage. No, I'm just kidding. But it's not safe, so it's difficult to do sometimes these inspections. Control devices, sometimes they're really high and so forth. And the lack thereof of records or good records. I haven't found anybody with good BBCC records yet, but it's new. Vapor pressure determination is important because the higher the vapor pressure, typically the more volatile. It defines the boundary between level 1 and level 2 tank requirement. They can do it by knowledge or analytical method. If they don't have knowledge or determination, then sometimes the company will say, we're going to do level 2. We're going to have our vent from our tank go to a carbon absorber or to a thermal combustion unit. Because we make a lot of things in this factory, and we have fluctuating waste. So we're going to do level 2. We're not going to deal with the conservation vents in level 1. So they'll get an activated carbon system for their vents. Conservation vent, you all heard the term? I know some of you probably have. It's a vent a vent that goes on top of a tank top. Only opens when they're putting waste into the tank, and then it closes. So it has a preset pressure, usually very low. It opens up when it's being filled, so the tank doesn't overpressurize and become a safety issue, and it closes. Problem is they sometimes don't seat. They don't seat very well, and they're open, and they're just venting. They're years old. No one's checked them. Level 1 is easy because it's a fixed roof. Okay, with that big 18,000 gallon tank at the fuel facility, fixed roof, typical tank with a small vent, that's level 1. They didn't have activated carbon for that one. They didn't need it, but they had to have a conservation vent that had to be, redone. But the fixed roof openings, so we're talking about hatches, manways, lids, caps, all those need to be closed. So if you're going on top of a tank or you're looking at it, it's not very tall, and you see cracks and holes like that one I showed you with the totes in the beginning with the air pressure pump or the electric pump that had gaps, and that's why the VOCs are so bad. If they have vents in it, openings in it, it's not level 1, and you get vapors in the room, vapors emitting into the atmosphere, and that's usually a very significant violation. That's usually a fire hazard as well if it's D001. Kind of an example EPA gives what they consider like a fixed roof one. These are common problems at level 1 tanks that I've seen. Closure devices that have been left open, hatches and caps not closed, the bolts are missing from manways, manholes. Gaskets and O-rings are no longer good, and conservation vents are a problem. Level 2 is RCRA hazardous waste that's exceeding level 1 criteria, or needs to go to level 2 because they can't meet level 1. And they get, like I said, fluctuating organic waste. If they haven't done a maximum organic vapor pressure determination, they got to go to level 2. So one thing I asked the generator is, I know you got organic waste, I see your manifest, I see your row profile, what is your vapor pressure of the waste in your big tank? And they're like, huh? You know, and I go, well, if your vapor pressure is a certain level and it exceeds that level in the reg, you have to have level 2. If they don't have a vapor pressure, it's automatically level 2. So I said, I mean, you guys need to do it by knowledge or by testing. There is a method for determining vapor pressure. Level 2, as you'll see in a second, is these 5 choices. More detailed, more problematic if I'm a generator. But number 1 is the first one you'll see common, is just a fixed cover vented dual control device. Activated carbon, thermal combustion system for burning off the vapors. That's what I see for level 2. The other ones, pressure tank and a site of closure, fixed roof, external floating roof, I haven't seen. You'll see it at TSDFs. So has anybody done a TSDF inspection and done a BB CC? No? Okay. Vapor recovery units, there's 2 types that I've come across. Condensers, condense the vapors to a liquid. And activated carbon, very common at LQGs, that are venting something from a tank or from a process to scrub out, absorb the VOC. We're almost done. Containers, probably another 5 minutes, I think. Containers are subject to CC. There's 3 levels of control. EPA can't do anything, it's got to be more than 1 item. They got to do 3, 5, 10 items. It's like the EPA. And the thing is, I've been out with EPA inspectors at LQG inspections, and they haven't been doing it. And so I'm like, when the attorney said we're going to start doing it in California, I'm like, you guys have been down in San Diego a few times the last 5 years, and they're like, oh, 3 o'clock, we got to go on a plane back to San Francisco. It's like, so. But I mean, I'm like, BBCC, and they're like, oh, let's just look at the satellite areas, and labeling and container closing is what EPA, I think, is, and we're to have a good Mexican meal in San Diego kind of a thing. Is anybody from EPA here? Uh-oh. I love EPA. Level 1's easiest, most common. Level 3 is hardest. We'll talk about the levels. Level 1 is keep the RCRA hazardous waste containers closed. Everybody knows that. Everybody's trained for that. Small containers are not subject to CC. So if you have a 26.4 gallon or less than that, you don't have to meet the BBCC or CC requirements, excuse me. And satellite containers are exempt. Okay. Level 1 is containers that are less than 122 gallons or larger than 122 and don't have light material, highly volatile waste. Level 2 is bigger, more than 122 gallons, like a tote, and manages hazardous waste and light material service, higher vapor pressure. Level 3 is where it's more than 26 gallons in size and they're treating. Not common. I thought level 3, when I first read this, I go, oh, all the resin guys that I've ever inspected, I'm missing this whole thing. But then I tried to find answers on waste resin. Are they subject to level 3 controls, which is very elaborate. You'll see in a second, very extensive. But, I saw a letter to EPA from the Resin Industry Association saying, we're not really doing waste stabilization, we're doing a curing, which is more of a chemical reaction. So the resin industry was telling EPA, we're not stabilizing. Waste stabilization is fixing the waste with a binder, like cement or something like that. That's what waste stabilization is, to make it less mobile. And the resin industry was telling EPA, we don't think we're subject to CC requirements. Because how many resin companies, generators that will treat resin in an open container, put in the catalyst or a heating element to cure off the resin. So kind of a thing. For containers, they have to inspect them to make same thing they're doing, really, inspecting 90-day containers. No additional requirements unless level 3. Very easy. If the hazardous waste container meets DOT packaging, it's very easy to comply with CC. But sometimes the larger sized containers and totes, Sometimes they're old, they're missing caps. They got the replaced cap that doesn't fit right. It's not DOT compliant. It sits there. You know, DOT, the shipper, the carrier will not accept it. Those are the ones I've seen that have been problematic. You know. Leon took this picture. This is perfectly okay. You're not violating CC. It's a D001 waste, and they got a little vent to vent out. But the only caveat to comply with CC is that that thing has to close when not in use. So it automatically opens up when it senses head pressure and closes. And so that's the only thing that, for safety vents, perfectly legal. If it stays open, that's a violation, not only of the open container rule, but of air emissions for RCRA Organic. This is a hospital, Leon? Hospital? Medical center, yeah. Again, level 1's easy. Three control measures. DOT regulations is meet a container that's DOT compliant, tight fitting covers. I haven't seen one use a organic vapor suppression barrier, you know, where they actually put a suppression barrier, a foam, on top of the waste in a container. It's possible. It's allowable. And that vent I just showed you, it's okay. The DOT, the Subpart CC containers is really heavy on, you know, a DOT compliant container. So the container's got to meet DOT specs. If the container is, you know, looks like a dumpster and stays on the business site, and they got a tight fitting lid, but you know, you could pretty much smell the vapors and see the problems. That's not a DOT compliant container, and so that means they would have to have, you know, a vapor control, emission controls possibly on the container. So if you see flammables in a plastic drum, is that DOT compliant? So it takes a little bit of work to understand the DOT stuff, but that's what EPA allowed for level 1 control. You know, just put it in a DOT compliant container, keep it closed. If it isn't DOT compliant, they kind of fall into violation for that, you know, container of organic waste. You know, and a container that's heavily corroded, dented, is not DOT compliant. One that has a makeshift. We had a company, a pharmaceutical company, use a styrofoam plug to put the styrofoam plug on the missing vent cap on a 55-gallon drum, and the styrofoam plug was not compliant. You know, and the reason why I did it is they had a little transfer hose that came from the lab that was on the other side of a wall, and it was going through the styrofoam plug I go, buy a decent threaded plug. Go online and you'll find it. And you'll get one with metal, you know. Level 2 is, again, meeting DOT requirements is okay. It's usually a bigger container, like a tote, that's DOT compliant. They can actually do EPA method 21, you know, sniff the container and make sure there's not getting emissions and be compliant as well. Okay. But again, containers are very broad. You know, I'm showing you a picture of a drum and a tote. But remember, containers could be rail cars. I did an inspection of a site that was using a old stainless steel milk tanker for storing their hazardous waste in it. And then it wasn't DOT compliant, CHP compliant. And they had all their waste in this 3,000-gallon milk truck. And that was a container. It wasn't a tank because it had wheels, kind of thing. Dumpsters, rail car, like I said, rail cars. There's all kinds of containers out there, not just 55-gallon drums and 5-gallon safety cans and so forth. Level 2, no splash loading. One of my businesses had splash loading, and they had a VOC. They opened up the hatch, put the hose in, and just splash out and you know, stand upwind, and then close it. That was not compliant. It's got to be a submersible fill or a tight-fitting connector. That could be done. That's what I told them to do. Get a tight-fitting connector, threaded connection. No splash loading. It's a health issue as well as a safety issue. Level 3 is for waste stabilization. They have two choices. For that treatment container, they got to go through a closed vent system to a control device, like have that container that's doing treatment closed, do the treatment inside the container, and then the vents, it's going to be vented to like activated carbon or to a thermal combustion unit to burn off the vapors. Or they could build a special enclosure at a huge expense and have the container inside an enclosure. That usually needs engineering, massive amount of engineering to design that container. Transfer requirements the same as level 2. And level 3 enclosures, they point to the 40 CFR, which is, you don't want to read that. It's a lot of engineering stuff. And in San Diego, finishing up here in a second, we decided to have our VOC detection team. That's Buster. And so I tried to convince my boss, let's hire him, let's train him to detect VOCs. He's a good sniffer. He works cheap, dog biscuits. He's really good. You can smell bacon from a mile away. But I haven't got permission yet. So in a nutshell, I think we're done. They're a little more intricate, the regulation. They're not scary to me. I mean, they shouldn't be scary. If you're doing intermediate, advanced inspections, they shouldn't be something to lose sleep over. And the inspection guide, I wrote one. I presume a lot of people got it by email. It's on the Cal CUPA website. It's 65 pages. I would say of those 65 pages, 55 of them aren't applicable to a lot of TSDS, because like pressure tank. I have a page on pressure tanks. I have a page on enclosures. They're not going to apply. So really, there's only going to be a few pages in the guide inspector of business will be using. What is my monitoring frequency? What is my waste determination? Is there an exemption? What is my control device allowable? Is it activated carbon? Is it thermal combustion? Whatever. So hopefully that all helps. And the last thing, let's see. Try and communicate to the businesses early. I'm sending out letters to businesses I know that are subject to it and saying, I think you got a BBCC, you look into it. If you're an inspector of business, kind of look at these regulations and do some self-teaching. It's not hard. Don't use a hammer. I mean, don't go in, next week to a place and close them down, because that will be kind of harsh. Devise a plan, implementation plan if you're a business, LQG generator. Don't wait, because I think this may actually get around the state where inspectors may start to look for it. Identify LQGs, and then if you're a regulator or a business, get some assign your expertise. Have your key people, become your technical leads, and then help them best you can. And then you don't want to kind of like give it to all 35 inspectors that we have in San Diego, because the ones that just got hired, like started 6 months ago, they're not going to get it. I mean, they will get it. Some of the ones that are really sharp, like Hosty, they'll probably get it better than me. But a new person will be overwhelmed. They'll probably want to go like work for a pharmaceutical or something. I don't know. And last thing, if you're a supervisor, it really is the supervisor's job to implement this. Like I told my staff, and I'm going to make you guys do this, and so you guys should learn it. And so be the driving force. If you're a supervisor or manager, don't wait. Because to me, the clean air requirements are pretty much, climate change and clean air and things like that. We should be implementing that, because California has got a lot of hydrocarbons that are used every day, every second. And so if we can minimize the release, hug a tree, and part of a step, if you're going to do an enforcement case, I always like, let's plant trees. Instead of a fine, maybe, because I think trees are like, in San Diego, we are devoid of trees in some places. So let's plant some trees, because that's a great way to influence climate change.